Hello, this video is going to show how we can achieve functional safety using the Synopsys Arc MetaWare development kit and a Arc EM starter kit that I have connected to my laptop at the moment. Now the starting point is of course a project inside the MetaWare IDE. I've got a number of particular projects here for various different Arc devices, and the one I'm using here is this Arc EM4, and this is a simple project that I can run on that evaluation board that I showed earlier. So first of all, let's check we can actually build the code. So here we can see we've successfully built the code. And now what I'd like to be able to do is, first of all, I'd like to be able to look at this code and see, well, is it compliant to a particular coding standard? I'd like to be able to look at the quality of the code and find out, well, how complex are some of these functions? And then I'd like to be able to execute the code and find out, well, as I execute it, how much of this code have we actually exercised? And then finally, I'd like to take some of these functions and actually unit test them with a unit testing tool. So starting point is we've shown we can build from within here. Now I'm going to invoke the LDRA build system import, and I'm going to run the same build here, but this time inside of this tool. So here we can see it's invoked the build, and we've listened to what's happened, and we've seen we have generated an executable. We have a list of the source files. We have a list of the include paths, and also a list of the preprocessor symbols. So we have everything we need now in order to be able to analyze this code, and I could open it with TB Vision. Well, to save time, I've already done that. I've performed the analysis. So now I'm going to be able to go and do a code review. And here we can see we have quite a few violations. This code wasn't written to be compliant to MISRA, and so we have a number of violations. If I was to double click on a particular violation, it opens up the source code and shows me where that violation occurs. In this case, I've got an unsigned value, so really I should have a U here. So very easy to fix. Well, let's go back and take another look at something else. This time, let's look at the quality of the code. Let's take a look at maybe a system call graph. And the system call graph is showing us all the functions. We can see how they're interconnected. We can see that this is colored in green because it's a system call. And we can look at this in various different modes. Maybe the most interesting is the maintainability view. And here I can sort and rapidly find the most complex function. And we can see the integer to ASCII function has a cyclomatic complexity of 9. Well, let's view that in a flow graph. And so here we're going to get a graphical representation of that code. And if I was to click on a particular block of code here, we can see the corresponding block over here. If I was to click on this particular block, we can see it corresponds to this one here. What about this? This is a branch. It's a branch from here up to there. So this allows me to very easily understand the structure of the code. Now, what I'd like to be able to do now is to execute this code on the target. And as it executes, I want to be able to find out, well, how much of this code have we exercised? And so I'm going to instrument the source code, and I'm going to put probes at the start and at the end of each block of code. So let's go and do that. So I'm going to close this down. And if we take a quick look at the main, what we're going to see is the main is basically just calling a functions a certain number of times and then is going to exit. So we should at least be able to get some coverage by executing this code. Right, so let's go and perform the dynamic analysis. So this is going to first of all instrument the source code to insert the probes. It's just built it, it's executed it on the target, and we've got the coverage back from the target. So what coverage did we obtain? Well, let's go back to our system call graph, and this time we'll put it into a coverage view. And there we can see we have 100% coverage for all the functions, apart from the most complex one, this integer to ASCII function. Well, let's view the coverage on a flow graph. And now we've color-coded in green to show us the paths we've taken, and in red, the paths we haven't taken. So we can see we have some branches here that have not been executed, and we've got some blocks of code that also not been executed. So if I want to get full coverage on this, then we could run some test cases with the unit testing tool, tbrun. So let's go and invoke tbrun. So inside tbrun, we're going to be able to create test cases. In this case, I'm simply going to open a sequence of test cases that I've previously created for this integer to ASCII. Okay, I'm just going to accept that. And there I've got 7 test cases. Each one is using different inputs. And here we have the expected outputs. So let's go and execute this. So that's generating a harness. It's built it. It's downloading to the target, executed on the target. We've got the results back. We can see that the tests, first of all, have passed. So with these inputs, we got the expected outputs. And at the same time, we've measured the coverage. And as we can see with the integer to ASCII function, we've got 100% statement coverage, 100% branch decision coverage, and also 100% MCDC. Okay, so hopefully that's given you a quick overview of how we can work with the ARC MetaWare Development Toolkit. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.